Chapter 4, Section 1, we're going to start graphing the sine and cosine functions and learning how to shift those graphs. So in Algebra 2, you guys worked with absolute value, quadratics, piecewise functions. This is just another function to learn how to move and graph based on the equation. So both cosine and sine functions are considered periodic functions. So f of x equals f of x plus np. P represents the period of the function, which is like your end point. It's like how, where you end once you complete one cycle of either sine, cosine, tangent, and all of those functions. So for both sine and cosine, the period is 2 pi. That's because when we go around the unit circle, you go from 0 to 2 pi. So the sine and cosine function goes one loop around that circle. That is the period of those functions. So if we look, we have the parent function for sine. So we have f of x equals sine x. So when we go to graph this, we're going to look at those quadrantal angles. So you got 0, 90, 180, 270, and 360. But when we graph, we're going to work with radians. So we actually have 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So 0, pi over 2, pi, 3 pi, and 2 pi. 3 pi over 2, 2 pi. So when you're looking at those functions, remember that sine is also your second value on your unit circle. But when you're at 0, the sine is also 0 because you're on the x-axis. So 0, 0. Pi over 2, you're up there at that 90-degree mark. So technically, remember that sine only goes between -1 and 1. So pi over 2, you're going to be at 1. When you're at pi on the unit circle, your y value is 0 again. And when you are at 3 pi over 2, you're at -1. And when you are at 2 pi, you're back at 0. You're back at the beginning. So our interval is going to be between 0 and 2 pi for the home function, for the parent function of the sine function. Domain is -infinity to infinity because you can go around that circle multiple times. You don't have to stop at 2 pi. 2 pi is just one cycle. And your range for the sine function is between -1 and 1. So when we go to graph this, we're not going any higher than 1, and we're not going any lower than -1. And then we're going to start at 0. My first notch is going to be pi over 2. My second notch is going to be pi. My third notch is 3 pi over 2. And then my last notch is 2 pi. So those are my x values. My y values, I'm going to go 0. At pi over 2, I'm at that maximum point of 1. At pi, I'm back at 0. 3 pi over 2, I'm down to -1. And then 2 pi, I'm back at 0. So then we have a curve that looks like this, and it will go in the negative direction as well. So it continues on forever. That's what those arrows are there for. And then a trick that my trig teacher taught me to remember the pattern of the sine function. Sine, as long as you're starting at 0 or one complete cycle, always starts at 0. So it goes 0, and then I go to my max, and then I go back to 0, and then I go to my min, and then I go back to 0. So my trig teacher always told me to remember 0 max, 0 min, 0. And that is something that has stuck with me all these years. So then we have the cosine function, and sine and cosine are somewhat related. Cosine, of course, focuses on your x value. So again, just the parent function for cosine, we're going to have those same points. We're going to have 0, pi over 2, pi, 3 pi over 2, and 2 pi. However, when you're at 0 on the unit circle, cosine also is based off the unit circle. When you're at 0, you're going to be looking at that x value in those parentheses. So when I'm at 0, I'm technically at 1, because remember the radius of the unit circle is 1. So when I go up to 90 degrees, or pi over 2, my x value is 0. Then when I'm at pi, I'm at negative 1. 3 pi over 2, I'm back at 0. And 2 pi, I'm back at 1. Domain's still going to be the same. It's going to be between negative infinity and infinity. Your interval, because nothing has changed, is still 0 to 2 pi. So your parent function interval is always between 0 and 2 pi. It's once we change the period is when that interval is going to change. My range is still between negative 1 and 1. And then my trick for this, that my trig teacher told me, was you start at your max. So we start at our maximum value, then we go to 0, then we go back, then we go to our min, then we go back to 0, and then we end on our max. So max 0, min 0, max. Again, another thing just to keep in your head. So then the cosine, pi over 2, pi, 3 pi over 2, and 2 pi. Cosine is going to start at its maximum. So I'm going to go max when I'm at 0. Then when I'm at pi over 2, I'm going to be at 0. And then at pi, negative 1, back to 0, and then back to my max. So it kind of looks like a parabola. It also kind of looks like an absolute value graph, but technically these are going to curve. So that is one cycle, one period of your cosine function. As we get on to example 1, those were just the home functions. Now we're going to start to change some things. In example 1, we are changing the amplitude. So A represents the amplitude, and the amplitude is the height of the graph. So it's the height of your graph. So in this example, we want to graph y equals 2 sine x. In this case, a is equaling 2 because it's right there in front of the function. So in blue, I already have graphed our parent function. I have what we just graphed, the parent function back at the beginning of this lesson. So when we're at 0, we're at 0, then our max, then 0, then min, and then back to 0. So now we're going to see what happens when I change my amplitude. So when I'm at 0, instead, I'm still going to be at 0. So if I was to say the sine of 0 is 0, multiply that by 2, it's still 0. If I plug in pi over 2, sine of pi over 2 is 1, so 2 times 1 is 2. When I plug in pi, sine of pi is 0. 2 times 0 is still 0. When I plug in 3 pi over 2, the sine of 3 pi over 2 is negative 1. 2 times negative 1 is negative 2. And when I plug in 2 pi, sine of 2 pi is 0. 2 times 0 is back at 0. So the only thing that's changed is my height. I'm no longer graphing to 1. I'm graphing to 2, and I'm graphing down to negative 2. So your amplitude changes your y, or your output value. So it's going to change whatever you get out of the function. And your amplitude can never be negative, so even if that was a negative 2 in front of that, it would technically just be the opposite. Instead of going 0 max, you would go 0 min. And that's something to note. So if it's negative, you're not going to go up to your maximum. You're going to go down to your minimum first. So when we go to graph this, I'm still going to have 0, 0. At pi over 2, I'm going to go up to 2. Then I'm going to go back to 0. Then I'm going to go down to -2. And I'm going to go back to 0. So then we have 0, our maximum at 2. And then we're going to go down to our minimum at -2. And then we're going to go back to 0. So in red, you can see the height difference of 1 unit. So that's what we graphed. That's our new graph. In red, we have y equals 2 sine x. In blue, we have y equals sine x. So that is the difference, and that is how you graph the change in your amplitude. In example 2, we're going to change our b value. So in the parent function, b is 1. That's meaning that our period does not change. B affects the period. So B represents a change in the period. The period of the graph changes your x, your input values. And the equation to find your period, so once there's a change in B, you have to find the new end point. And the equation to do that is 2 pi over B. So technically in the parent function, b is 1, 2 pi over 1 is 2 pi. That's why the period of the sine and cosine graphs is 2 pi. So there's some steps that I like to tell you guys about how to graph your change in your period, because it's affecting your x value. So it's not as simple as saying, well, my normal height is 1, I'm going to multiply that and change that, and it's just going to go up to 2. This is going to change those x values along the x-axis. It's not going to change anything with your height on your y-axis. So step 1 is to find the period to create your new interval. So when you find the period using the 2 pi over b, you're going to create a new interval. So it's no longer going to be from 0 to 2 pi. It might be from 0 to something else. You want to find your midpoint from that new interval. So you're going to take 1/2 times your starting point plus your ending point. So if you were going from 0 to 2 pi, that's 2 pi. 0 plus 2 pi is 2 pi. Half of that is pi. So your midpoint on your x values is pi on a normal graph. So then you want to find your quarter point. So you would find quarter point 1. You're going to take 1/2 times your start plus your midpoint. So whatever you get in step 2, start plus midpoint, and then half of that is going to be your quarter point. And then your second quarter point is going to be half of your midpoint plus your end point. So from the middle to the end, you want to find the point in between those two. And then you're going to label your x and y axis and graph. So if we want to graph y equals sine 2x, b in this case is 2. This is my b. b equals 2. My period is then going to be found by taking 2 pi over b. So it would be 2 pi over 2, which is going to just equal pi. Okay, so my new interval is going to be between 0 and pi, because the period is my end point. My midpoint from that, I'm going to say 1/2 times 0 plus pi, and that's going to equal 1/2 times pi, because 0 plus pi is pi, which will just be pi over 2. So my midpoint is pi over 2. To find my Q1, I'm going to go 1/2 my starting point to my midpoint. So 1/2 of 0 plus pi over 2, which is then 1/2 times pi over 2, which is then going to equal pi over 4. So we want to keep this in terms of pi. So pi over 4 is my quarter point. Then to find my second quarter point, I'm going to take 1/2 times my midpoint plus my end point. So remember, you can't add these because they don't have the same denominator, so you got to change that. So it's going to be 1/2 of pi over 2 plus, if I multiply this by 2 over 2, 2 pi over 2, which would then be 1/2 of 3 pi over 2, which is going to be 3 pi over 4. So then when you go to graph, you're going to have your start, which is 0, then Q1, which is pi over 4, Q2, or your midpoint, which is going to be pi over 2, then Q2, 3 pi over 4, and then your end, which in this case is pi. So these are now my new x values. So we have 0, pi over 4, pi over 2, 3 pi over 4, and then pi. So this time we're going by quarters. But guess what? Nothing changes when it comes to the height of your graph. You're still going to follow the same pattern. So when you're at 0, you're at 0. When you're at pi over 4, you're at your max. Pi over 2, you're going to be back at 0. 3 pi over 4, you're going to be at your min. And then at pi, you're going to be back at 0. So when we go to graph this, we'll have 0, then my max, then my min, or no, back to 0, and then my min, and then back to 0. So when I go to grade these kinds of problems, I'm going to be looking to make sure that you have your x values correct. Technically, if we were to write them all on the number line, your graph would be a little bit more squished because we're going by quarters instead of by halves. So that would be the change there. It would get more squished together, making it smaller this way on the x-axis. And those are the only two examples I'm doing right now in Chapter 4, Section 1. We will do more examples next week. I didn't want to overload you guys with graphing before the weekend. So your homework on just those problems on example 1 and example 2 is page 149, 14 to 20 even. And that should take care of just examples 1 and examples 2. We're going to take our time through graphing. I do want to finish it up before Thanksgiving break, but we will be taking our time through this chapter, through graphing itself, just so you guys know in advance. And if all of this, you will definitely have a test on just graphing before Thanksgiving break. So that's graphing sine and cosine, graphing the parent functions, and then a change in the period and a change in the amplitude, and a change in A and B, pretty much.